You are watching the 5.7 lesson video on Factoring Trinomials Day 3. So naturally, because we're in the third day, we are going to have a little bit more to think about. However, the process that we're going to be using is exactly the same as what we've done in the past two lesson videos. So in order to factor each of our trinomials, we are usually going to set up the box method. So let's get started. All right, with number 1, I'm going to set up my box. And I'm hoping that you guys have gotten the hang of this by now, but we're going to put the x squared term, this first term, right in this top left box, the constant in the bottom right, and then my tail of these two boxes, when we add them together, needs to become a positive 18x. Okay, so the reason why this one or these types of questions are a little bit more challenging is just because we have a lot more guessing and checking to do. So to get 9x squared, we could multiply 3 times 3 to get the 9, or 9 times 1. So I'm just going to write that off to the side. So we could either have 3 times 3 equaling 9 or 9 times 1 equaling 9. I am going to try 3x times 3x first. But I do know that if that doesn't work, then I'm just going to have to try 9 and 1 at some point. Okay, so I know that 3x times 3x is 9x squared. Then what I'm going to do is I'm going to think of numbers that multiply to 8. So I have 4 times 2, and I have 8 times 1. Now, great news for us is we're dealing with all positive numbers, so I don't have to worry about the negatives. So that helps eliminate a lot of different possibilities for me. So I guess I'm going to try 8 and 1 first. Okay, so 3 times 1, or 3x times 1 is 3x. 3x times 8 is 24x. Oh, that's not going to get me to 18x. Okay, so one option I have is to flip-flop my 8 and my 1, but because both of my coefficients right now are 3, that's not going to change much. So that's good. I don't even have to try that. All right, let's try 2 and 4 next. 2 times 4, again, they both have to be positive. So here I get 6x and 12x. And OMG, guys, 12x plus 6x is 18x. We have found our answer. So factored, this becomes 3x plus 4, all times 3x plus 2. Notice how all I do is I take one side and put it in one set of parentheses, the other side of the box and put it in the other set of parentheses. And if I want to check my work, let's just do this on the first example. Remember, we just type in our original, and then we type in our factored form, and make sure that the two line up. So hit tab, and then we're going to type in 3x plus 4, all times 3x plus 2. If we did it right, it should work out. Yay, we're great. All right, let's go on to number 2. So number 2, we have another trinomial. You got it, set up that box. All right, we should be pretty fluent with this right now. I am just going to write a minus 1x just to keep me in check. All right, so now I need to figure out two numbers that multiply to 6. Well, I have 6 times 1, 2 times 3. Uh-oh, I have some negatives, so this can spice things up a little bit, but let's think about all the numbers that multiply to 12. 1 times 12, 2 times 6, and 3 times 4. Okay, so I am going to try first, let's see, maybe we'll try 3x and 2x. Again, that could change if my numbers don't here, or my numbers here don't work, but let's just keep going with this. All right, two numbers that multiply to 12. I'm going to try 6 and 2. I know one of them has to be negative, and it's going to have to be my bigger quantity. So let's see what happens when I multiply these through first. So that gives me 6x, and that gives me 12x. So this has to be my negative number, but 6x and negative 12x won't be negative 1x. Okay, that's fine. I'm going to flip-flop the 6 and the 2 to see if that helps. So I'm going to, sorry, my screen's jumping all over the place today. So I'm going to put the 6 down here and the 2 up here. So there I get 18x and 4x, and even if I make, they're definitely not going to work. Okay, so I'm thinking that 6 and 2 are not my answers. That doesn't mean that they're not, because I could definitely try 6 and 1 for these two values here. But instead I'm going to try, let's say, 4 and 3. So I'm going to put the 4 here and the 3 here. So I get 12x and 6x. 12 and 6, even if that one's negative, won't ever get, or even if this, I guess the other one had to be negative, but either way, not going to work for me. Okay, so we know that the 4 can't go here, so I'm going to try putting the 4 up here and the 3 down here. So I get 9x and 8x. Oh, wait a minute. If my 9x is negative, that means my 3 is negative, and look at, we found it. Negative 9 plus 8 is negative 1. So I wanted to show you the rigor that sometimes these questions might have. Okay, so we did a lot of different guessing and checking. All right, let's go on to question number 3. Number 3, another trinomial we need to factor. You know the drill. Let's set up the box. So 4x squared. It's got to combine to negative 4x. Being careful with your signs is critical. All right, so how do we get 4x squared? Well, 2 times 2. We could also do 4 times 1. All right, I'm going to try 2x times 2x, but also it could be 4 times 1, just to keep that in the back of our mind. So if we exhaust all of our options and we're like, why are none of the other numbers that multiply times 3 working? Probably just means that we got to switch around the 2 times 2 to be 4 times 1. All right, let's think of some numbers that multiply to 3. Oh, this is good. We either have 1 times 3 or, 1 times negative 3 or negative 1 times positive 3. Okay, I'm going to try positive 1 and negative 3. Let's see if that works. So that gives me negative 6x and a 2x. Would you guys look at that? We got it on the first try this time. That doesn't always happen, but we got it. Sometimes I might have to flip-flop where my numbers are, remember. So sometimes I flip-flop numbers, sometimes I flip-flop signs. Remember, I can't say it enough, there's a lot of different options, and sometimes we need to try a bunch of them before we find the right one. It doesn't mean that we can't do it, it just might mean it takes us a little bit longer. Just to reiterate what we did in question number 1, if we wanted to check, graph the original, graph the factored form, make sure that they match up. Okay, now number 4, this one here is a binomial, and it's the difference of 2 perfect squares. So I'm subtracting 2 perfect squares. This is wonderful news for me, because a lot of these times with these types of questions, I don't even need to set up my box anymore, because the difference of 2 perfect squares is going to follow the same structure every time. So what times what gives me 36? 6 times 6. Has to be the same number, remember. And then obviously x times x. What same number multiplied by itself gives me 25? 5 and 5. One of them is plus, the other one is minus. Now, for those of you that were like, whoa, how did we do that? I'm just going to show you very quickly the box method of how this looks and why this works. But some of you are learning why this works. Well, because we're trying to find things that cancel to be 0. And the only way that these will ever add to be 0 is if it's the same number, one of them is positive and the other one's negative. So in this case, this would have to be a 5 and a negative 5 to multiply it by negative 25. And here, 6x times 6x is going to force these two numbers to be the same, right? Because if we use like 36 and 1, or really like 9 and 4, these two would not cancel out to be that 0x that we wanted.